Okay, another probability question here. So we got n red balls and n plus 1 blue balls. Okay, so we want to work out probability that she's going to take 2 balls at random from the bag. So let's do the probability of red followed by red to start off with. Now we can see that there's n red balls, and then altogether we've got n plus 1 balls altogether, which equals 2n plus 1 balls altogether. So those n red balls come out of 2n plus 1 balls altogether. On the second ball, there's n minus 1 red balls left in the bag because we've taken one out. And we take one off this because we've taken a ball out of the bag, we get 2n. So probability of red followed by red will equal what we got here. We've got n times n minus 1, and then we've got that over. I'm going to put the 2n first, times 2n plus 1, because then it's easier to see the cancelling I can do. Now you can only cancel where you have a common factor top and bottom. So we can cancel out the n because you've got n times everything on the top, and we cancel out with that n because there's n times everything on the bottom. So you must have that to cancel. We can't cancel out anything else. Okay, that's all. So this is equal to n minus 1 over 2 open brackets 2n plus 1. We've cancelled out those two n's here. Okay. Right. Let's move that. Give ourselves a bit more space. So I'm going to do probability that we got, was it blue? Blue followed by blue. So there are n plus 1 blues in the beginning over 2n plus 1 times by, if you take 1 off the n plus 1, you're left with just n. Take 1 off the 2n plus 1, you're left with just 2n. And straight away, we can see we've got a common factor top and bottom, so we can cancel that down. N into n goes once. And obviously n into n is once. That's going to just leave us 2. So when we do the top times together, we get 1 times n plus 1. Now we've got 2 times 2n plus 1 on the bottom. So that's the probability to get blue followed by blue or red followed by red. So now the probability of the same is an OR situation. So we add these together. N minus 1 over 2 brackets 2n plus 1 plus n plus 1 over 2n plus. I've made a mistake. There should be, there's a 2 and there's a 2n plus 1 there. So I need another 2n plus 1 here. Because I've got 2 times 2n. So that should be 2. 1. I could see that mistake was coming because I wanted my fractions to have the same denominator. Because you need the same denominator to be able to add fractions. Otherwise you can't add them. And now we've got the same denominator, we can now add these fractions. So we can do n minus 1 plus n plus 1. That's adding the two tops. Get that. All over. Remember, we just have the denominator that's common to both, and we add fractions. If you imagine adding 1 quarter to 2 quarters, you just get equals to 3 quarters. Exactly the same idea where you just add the two tops. Okay, for those of you who are a bit rusty, adding your fractions. Same idea. Now n plus n is 2n. The minus 1 and the plus 1 cancel. We're just left with 2n on the top. And then we get that all over 2 open brackets 2n 1. And what can we cancel out here? Nope. Our suggestions of the n, which I can't, because no, you don't have n times everything on the top, you don't have n times everything on the bottom. We can cancel out the 2's because you have 2 times everything and 2 times everything. And that just leaves you n over 2n 1. And what do we notice? It's exactly what we prove. Okay? There's the thing we want to prove, and there's our answer. So we have done it.